Exercise 9C, yeah. Let's do that. Okay. Right, level 9C, yeah. Come on. Okay, yeah, let's start this then, yeah. So what we're looking at here is question 1A. Question 1A is 1 plus 2x, yeah, to the power of 4, yeah. Now, what you want to do, yeah, I'm going to do this way, and then in the future you'll get quicker with it, yeah. What you want to do here is, this is called the chain rule, yeah. This is when you got a function inside of a function, yeah. So effectively, the function here is 1 plus 2x. In a way, that's a function, yeah, because that's like an expression, yeah. And it's inside of this to power of 4, yeah. So that function is kind of like x to the power of 4, if that makes sense. You get me? So it's like 1 plus 2x inside x to the power of 4, yeah. So it's a function inside a function, yeah. So whenever you got a function inside a function, yeah, you need to use the chain rule, yeah. So chain rule, what you can do is you can write u is equal to the one that's bait inside here. So it's whatever's inside the function, yeah. So here's bait is just 1 plus 2x, yeah. It's just the biggest expression, yeah. So 1 plus 2x here, yeah. And then differentiate that, so it will be du over dx, because we're differentiating u in respect to x, yeah. So that will become 2. And then after that, you got y is equal to u to the power of 4, yeah. Now, why did I say u to the power of 4? Well, it's because 1 plus 2x, I call it u now. So therefore, that's u to the power of 4 now, is this whole thing. So then dy over du is equal to 4u cubed, yeah. If I bring 4 down and take away 1 from power, that's 4u cubed, yeah. And now what you do is you'll notice here that if I want to find it, dy over dx here, I'm going to have to times together du over dx times dy over du. The reason for that is because, as you'll see here, du and du will cancel and it will just give you dy over dx here. So that's what you do basically, yeah? You find u, you find y, you differentiate both, and then you times them together, yeah? So 2 times 4u to power 3, yeah, would be 8u to power 3. And we know that u is just 1 plus 2x here, so we can replace that here. So 8 plus 1 plus 2x here to the power of 3. Yeah, so that's the final answer for that, yeah? Alright, part B. Alright, save. So we got differentiate 3 minus 2x squared to the power of minus 5, yeah? So u is equal to 3 minus 2x squared, yeah? And then differentiate u, du over dx, so that's going to be minus 4x here. Okay, save. And now here we got y is equal to what? Y is equal to, we said 3 minus 2x squared is 3 minus 2x, yes, is u, yeah? So therefore u to the power of minus 5. So now dy over du is going to be, bring the minus 5 down, so that's minus 5, open bracket u, and then take away 1 from the power, so that's minus 6 here. Alright, save. So now what you want to do is you want to obviously times them together, innit? So times them together, yeah, minus 4x times that, yeah, is going to become minus 20x u to the power of minus 6 here. And obviously u is equal to, not minus 20, yeah, just positive 20, because it's negative times negative, yeah. And that's obviously going to equal 20x, and u is just 3 minus 2x squared here, so that to the power of minus 6, so that's the final answer here. Okay, come on. Alright, question C. So y is equal to 3 plus 4x power of a half, yeah. So what I can do is I can make u equal to the inside, yeah. So u is equal to 3 plus 4x here. And now du over dx is going to be equal to 4, yeah. Because you just differentiate that, you get 4, yeah. Okay, no problem. And now y is equal to u to the power of a half, yeah. Because this whole thing inside here is equal to u, yeah. So that's just u to the power of a half. And then after that, you're going to find dy over du. dy over du is just going to be, bring the half down, so that's half u. And then take away 1 from the half here, which is going to be minus half here. So we get minus a half there. Okay, no problem. Now we want to times them together, yeah? 4 times half u to the power of minus a half. 4 times a half is just 2. So dy over dx here is going to be equal to 2u to the power of minus a half, yeah? And now what you want to do is you want to, again, you want to basically write, instead of u, you want to write what it actually is. So it's 3 plus 4x here. So 3 plus 4x here to the power of minus a half here. Alright, d. Okay, so for d, yeah, we got y is equal to 6x plus x squared here to the power of 7. So what you want to do here is again make u equal to the inside, so u equals 6x plus x squared here, and then find du over dx. So that's going to be 6 plus 2x. And then find y, so y is just equal to u to the power of 7 at this point here, so u to the power of 7. And then differentiate y, so dy over du is going to be 7u 6 here. Alright, cool. Nice. So because of this situation, we're going to find dy over dx here. So dy over dx is going to be equal to times them together. So 7 times that is just going to 7 open bracket 6 plus 2x here. And then u to the power of 6. And that's obviously equal to 6 plus 2x. And then u to the power of 6 is just, u was 6x plus x squared here up here. So it's going to be 6x plus x squared here. Power of 6 here. Go. Alright, question E here. Y is equal to 1 over 3x plus 2 here. 3 plus 2x here. Okay, no problem. So that's just equal to 3 plus 2x to the power of minus 1 here. The reason for that is because 1 over x here is equal to x to the power of minus 1 here. If you got 1 over anything, it will be that anything to the power of minus 1 you get. So that's how you do that, yeah? So because of that situation, we got this now, yeah? So again, what's u then? We got u inside the function. So u is the 3 plus 2x here. So 3 plus 2x. Find du. Du is going to be 2. And then find y. So y is equal to u, because we said this is u. So inside is u to the power minus 1. So now we want to do dy over du. So dy over du. And obviously bring the negative 1 down. Bring negative 1 down here. And take away 1 from the power here. That's minus u to the power of minus 2 here. Alright, come. Now we want to find dy over dx here. To do that, to find dy over dx, you want to basically just times these two together, yeah? So that's minus 2, u minus 2, yeah? Because 2 times that, yeah? Okay, no problem. Now, obviously, we want to switch that out for what it's actually equal to, which is 3 plus 2x, yeah? So put 3 plus 2x there. And now we're going to get minus 2 times 3 plus 2x to the power of minus 2, yeah? And so that's the situation there. And now you just want to rearrange that, yeah? Again, so if I've got x to the power of minus 2, that's the same as a 1 over x squared, yeah? So here we got 3 plus 2x to the power minus 2. So that's same as 1 over 3 plus 2x to the power squared here. And the minus 2 just goes on the top. It's like being times by this whole thing. So it just goes on the top. So it'll become, what the fuck did I write that twice? Minus 2 over 3 plus 2x here squared here. Okay. F. So in F we got y is equal to root 7 minus x here. Now, square root, yeah, if you root something, it's the same as doing it to the power of a half here. So you're going to need to convert that to differentiate because you can't differentiate root here. So we've got this situation here. U is therefore equal to 7 minus x here. And therefore, du over dx is equal to minus 1 here. No problem. We got y is equal to, that's just equal to u. So it's just u to the power of half here. And now you want to find dy over du. So dy over du is going to be equal to half u, and then take away 1 from the power, that's minus half, yeah? Okay, so now what you want to do is obviously times them together, yeah? So minus 1 times that, so dy over dx here is going to be minus 1 times that, so that's minus a half here, u to the power minus half. And obviously, u is equal to 7 minus x, so it's just going to be minus half here, 7 minus x to the power of minus half, and that's the final answer there. Yeah, look at that, boy, yeah, we're moving through this. But wait. Now, obviously, that's not the end to the regime. There's another situation here, which is that we need to convert that minus half. Remember, when I said there's minus something, yeah, that means that you need to do 1 over it, yeah? So that's going to be 1 over 7 minus x half. That's what that is here. yeah, and then we're timesing that by minus a half. So you need to put minus there. One, when you times fraction, yeah, the top goes to the top, bottom goes to the bottom, yeah. So one goes to the top and two goes to the bottom, yeah. Now that's not done there because power of a half is the same as a root, as we said earlier. So that's minus 1 over 2 root 7 minus x. That's the final answer. Yeah? Obviously that half, you're just going to apply that onto the bracket and make that a root, yeah? No problem. No problem, fam. Too easy, yeah? Too easy. Alright, G. We've got y is equal to 4, 2 plus 8x, power of 4, yeah? So, okay. No problem. So u is equal to what? U is equal to 2 plus 8x, yes? What's inside the bracket is the inside thing, inside of the function, yeah? So that, calm. So du over dx here is going to equal to 8, yeah? No problem. Now, y is equal to 4 u to power 4. Alright, I know you want to differentiate y. If you want to differentiate y, you're going to get dy over du, yeah? Which is going to be 4 times 4, which is 16, and u to power of 3, yeah? So now what you want to do is you want to just times them together, yeah? So 16 times 8, yeah, is actually going to give you 128. So dy over dx is going to be 128, yeah, u to power of 3. So 128 u to power of 3, that's the same as 128, and u is actually 2 plus 8x, yeah? So 2 plus 8x to the power of 3, yeah? So there you go. So that's the answer, bro. There's nothing more to that. It's a very simple situation. And here we go, h. Now here we got h here is going to be what, fam? Y is equal to some next shit. Y is equal to 3 open bracket 8 minus x power minus 6 here. Alright, cool. So u is going to be equal to the inside, so 8 minus x. Du over dx is going to be equal to minus 1. Y is going to be equal to 3u minus 6. Yeah? And then dy over dx here is going to be minus 6 times 3 is minus 18 here. U and then minus 7 on top. Okay, cool. And so dy over dx here is going to be them two times together, yeah? So dy over dx here is going to be these two times together, which is going to be minus 18 times minus 1, that's 18, yeah? And then u to the power of minus 7, yeah? Which is also equal to 18, yeah? And u is obviously 8 minus 6. So that's 8 minus 6 to the power of minus 7. Okay. Question 2a. Question 2a, yeah? We're gonna do y is equal to 1 over whatever. Find the value of that at that, yeah? So we need to differentiate and put in the thing, yeah? So is it actually 2a or is it just 2? No, 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 I'm reading question 3. Okay, 2a is just the same shit that we just did, but, you know, using other situations. So e to the power of cos x here, yeah? So e is the function here. So e, remember, comes like that, bracket. And cos is another function. So cos is a function like that. So we've got function inside of a function, yeah? So we're gonna do the inside function. We're gonna make that u, yeah? So u is equal to cos x. So therefore du over dx here, you probably already noticed here, the ones that are smart from you, are minus sine x here. It's differentiating cos here. And then y is equal to, since cos x is u, yeah, that's e to the power of u. So therefore dy over du is just e to the power of u, yeah, because e differentiates into itself here. So that's just e to the power of u, and there's no coefficient. Alright, safe. So now we want to do dy over dx here. Dy over dx, I'm going to have to times d over dx times dy over du, yeah? So we're going to have to do minus e to the power of u sine x here, because that's minus sine x times that is going to give you that, yeah? Okay, no problem. And now we just substitute back in u, yeah? So u was obviously cos x, so it's just cos x sine x, yeah? Nice and easy, no problem. If we want the question B, yeah? Okay, let's see what B is saying. B is saying y is equal to cos 2x minus 1, yeah? So that's a function right there. And it's inside of the cos function, yeah? So u is going to be equal to 2x minus 1, the inside function. And then du is going to be differentiate that, so that's just 2. And then y is equal to, just substitute this for u, so cos u. And then dy over du is going to be minus sine u, yeah, because cos u differentiated is minus sine u, yeah. Alright, so now dy over dx here, I'm going to need to times these two together, yeah? So to times these two together, these two situations, it's going to be minus 2 sine u, yeah? And minus 2 sine u is effectively just minus 2 sine, open bracket, 2x minus 1, yeah? Because u is equal to 2x minus 1, yeah? So there you go. Okay, no problem. Let's move on to question C, yeah? Okay, cool. So we got y is equal to ln x here, root ln x. Okay, so u is the inside function, which is ln x here, and y is going to be this whole thing, which is root u, which is basically u to power of a half here, because I said square root is the same as power of a half here, so there we go. And then du over dx here, ln differentiates into 1 over x here, so du over dx is 1 over x. And then dy over du is going to be uh is obviously going to be half, bring the half down, yeah, and then take away 1 from the power, so minus half here, yeah. Alright, see. So now what you want to do is you want to times them together, so dy over dx is going to be them two times together, so 1 over x here times that is going to get what? You know what, let me just convert this now. So u to the power minus half here, if it's minus, I told you it's 1 over, so that's 1 over u to the power of a half here, and we're times them by 1 over 2, so 1 and 2 there, yeah. And then u to the power of a half here is going to be equal to 1 over 2 root u, yeah, because u to the power of a half is root u, yeah. So because of that, that times 1 over x is just going to be 1 over 2x root u, yeah, nice and easy. And obviously u is equal to ln x here, so it's just 1 over 2x root ln x here. Simple thing. Question D. It's actually very easy, man. Yeah, you might need to, plot the situation, know what's going on, and then apply it, and then you'll be calm. Okay, cool. So u is equal to the inside function, which is sine x plus cos x, yeah? Just break it apart like that. It becomes simple, yeah? It doesn't matter. I know this is a long method, yeah? Because obviously there is simpler methods, yeah? Sine differentiates into cos, yeah? But it's about getting the correct answer at the end of the day. At the end of the day in the test, yeah, you got time. You get me? You got time. You're not doing 100 questions in the test, bro. Like in the book. You get what I'm saying? You're doing a set amount of questions, yeah, not too many, like 20, I think, and it's all mixed. So you're getting one differentiation, one this, one whatever. Nah, not one. You're getting bare differentiation, but you get the point in it that I'm trying to make. So obviously, um, yeah, you need to just apply it fully. Take your time with it, innit? You can do it like this if you need to. Like, it's not a problem, bro. You know what I'm saying? As long as you get the correct answer, it doesn't matter. So as long as on that results day, you get that grade, it doesn't matter the ways in which it was achieved. You know what I'm saying? It doesn't matter if you're out here just being like, okay, bring the 5 down, 4 there, differentiate that times outside, or if you're doing this shit here. It doesn't matter, you get me? Okay, so you times these two together, so 5 u to power 4, open bracket, cos x minus sin x. And then obviously u is just whatever the fuck we had originally, sin x plus cos x here. So that's just 5 open bracket sin x plus cos x to the power of 4. Open bracket cos x minus sin x. Okay, save. E. Okay, we've got a sine 3x squared minus 2x plus 1, yeah? Come. So what's u then? U is going to be the inside function. So 3x squared, yeah, minus 2x plus 1, yeah? And then du is going to be what? Du over dx here is going to be that differentiated, yeah? So bring 2 down, that's 6x minus 2, yeah? Okay. Now y is equal to sine u, because this whole thing is equal to u. And so we want to do dy over du. So that's just going to be cos u, yeah? Cos u, because of u, yeah? You get that? Yeah. Joker. Alright. Dy over dx here is going to be them two times together, yeah? So these two times together is going to get you 6x minus 2 cos u. So obviously u is gonna get turned into something else. So obviously we need to do that right now. So u is gonna get turned into 3x squared minus 2x plus 1, yeah. So cos of 3x squared, yeah, minus 2x plus 1. Okay, and that's the final answer. It's getting a bit faded right now, math. You get me? Mm, I don't mean me, I mean the board, innit? Okay, cool. Question F here. It's saying ln sin x. Ln sin x, bit from that one there. Ln sin x here, it's a little situation here. So ln sin x here, u is basically equal to sin x here. And therefore du over dx is going to be cos x here. And then y is going to be equal to ln u because u is sin x here. So therefore that's ln u. And then dy over du, yeah, is going to be 1 over u, yeah. It would be 1 over x because ln x, but it's now 1 over u because we've got u, yeah. That makes sense here. So now dy over dx here is going to be equal to 1 over u times cos x here. So 1 over u times cos x here. Let's think about this. Let's actually think about this here. What would that be? That's going to be 1 over u cos x here. Okay, no problem, no problem. Now, what is 1 over u? You may be asking. Well, u was sine x. So therefore we got 1 over sine x cos x. Yeah? Very interesting, my friend. So that's obviously going to be times that up there. That's going to be cos x over sine x. And cos x over sine x, if you remember from the trigonometric identities, yeah, that's going to be cot in it. So cot x here, because it's sine over cos is tan, and then this is the opposite. This is inverse, so 1 over that, so it's cot here. So 1 over tan here. Alright, calm. G. So look, at the start of the video, you may not have been able to do this here, this 2e to the power of cos 4x situation here. But now we break it down, make it a little bit easier. You know what I'm saying? U is equal to the function inside, that's cos 4x here. Simple. Du is going to be, well, bring the 4 outside when you differentiate trigonometry here, so 4. And it's going to be minus sine, so minus 4 sine 4x, the inside stays the same. No problem. This is effectively chain rule, by the way, what you're doing in here. When you differentiate like a trigonometric thing with a coefficient, that's chain rule as well. That's the same as doing u equals 4x and doing all that shit in times, isn't it? Okay, now y is equal to 2e to the power of u. Okay, now dy over dx is going to be that differentiated, so basically the same shit, because e to the power of u differentiated is the same shit, so there we go. And now you just times them together, yeah? Do a little multiplication, yeah? If you know about multiplication. Yeah, me and my man go way back. And that's 2 times minus 4, yeah, which is going to be minus 8 e to the power of u sine 4x. And obviously e to the power of u was just cos 4x here, so that's just minus 8 e to the power of cos 4x sine 4x. Okay, there you go. Alright, calm. H, what, there's H to it as well? No, they're taking the piss, you know. Nah. Alright, calm. Y is equal to cos e2x plus 3. Listen, I don't know how you can, bro, if you don't go through all these questions here and watch these videos and go through every single question in the book here, I don't know how you can't get A star honestly, bro. Or A at least, or something, something. Obviously, I don't want to jinx it for certain man, but like, you get, like, it's looking peak, bro. I can't lie. At that point, you're gonna have to take the special advisories. You know what I'm saying? Because like, look how many questions there are of the same shit. You get what I'm saying? Bring the 2 down there, by the way. That's 2ex. Like, look how many questions there are of just the same shit. So like, at that point, cause you, by the way, yeah, because that's you. At that point, yeah, you're just repeating it again and again, which means that you should be able to, it should be locked in at that point. You should be able to do all these questions. If you can do all these questions legit, like not through mark scheme, like you look at this, you understand it, you go through with me, and you can repeat the same thing unprovoked, then that means that like you're 30, bro. At that point, there's nothing more to it. It's not that like crazy, yeah. That times that is minus 2e to the power of 2x here. And if you think it's that crazy, yeah, just look at some people in your class here. And look at the grades they're getting. Look at what they're gonna get in the June exam. Yeah, they're probably not gonna get that dead. Like they're probably gonna get at least C's. Okay, so like if they can get some C's, yeah, then you can get some A's and A stars. You know what I'm saying? And then replace the U here with obviously whatever U was. That's e to the power of 2x plus 3. Yeah. Alright, so for question 3, I'm gonna change whiteboard. Let's get into me. Okay, so for question 3, yeah. Y is equal to that situation. So y is equal to 1 over 4x plus 1, and I need to differentiate and put in some coordinate here to find the gradient at that point. Classic, yeah, classic. They call them, yeah, classics, yeah. Alright, safe. Let's do that then. Let's do that. So that's obviously going to be equal to what? That's obviously equal to, if you can clock by now, I said that 1 over x squared was equal to x to the power minus 2. Minus means 1 over. The power indicates the power that's underneath. So this is just going to be 4x plus 1, yeah, power minus 2, yeah. Alright, cool. No problem, yeah. U is the function inside, which is 4x plus 1. So that's that there. And then du is going to be du over dx is going to be 4, yeah? To differentiate that, you get 4. Y is equal to u to the power minus 2. I don't know why I said y like that, as if I'm, you know what I'm saying. Okay. Minus 2, bring it out there. Minus 2u, and then minus 3 up here, because you're going to take 1 from the power, yeah? And now what you want to do is you want to obviously times them together. So dy over dx is going to be 4 times minus 2, which is minus 8, u to the power minus 3. Alright, no problem. So now obviously, u to the power minus 3, I said if it's minus, it's 1 over. So that's going to be 1 over, and the power remains the same underneath. So 1 over u to the power 3, but it's being times by minus 8 as well. So you need to bring the 8 up here and make that negative here. Okay. And now, as the final answer, you just need to basically change u back into what it was here. So minus 8 over 4x plus 1 to the power 3 here. And now I think it wants you to do some shit with it. Okay, what the fuck? Okay, well, in my working out, I just, I decided to just, I guess, not write that. So I is what it is. I decided to differentiate and say fuck it. So here, what we got to do now, obviously, is we got to put x into there. So x is actually 1 over 4. So we need to do our 1 over 4. So minus 8 over 4 open bracket 1 over 4 plus 1 cubed here. So listen, if you put in a calculator with me, I can already tell what it's going to be, but we'll do it together. So minus 8 over 4 open bracket 1 over 4. Yeah, that gives you negative 1, yeah, so that's the answer. Alright, so you can obviously tell it's going to be negative 1, because you can tell that's 8, 4 times 1 over 4 is 4 plus 1. Which is obviously 2 cubed is 8, and then 8 over 8, yeah, so there you go. Alright, so that's the answer, yeah. Okay, cool, question 4. Question 4. The curve has that, yeah. Find the tangent to the curve. So tangent means that it's going to be the same x coordinate, I mean the same gradient, yeah. So we need to find the gradient and then make it the same, and then do y equals mx plus c equation. And obviously here they didn't even give us the y coordinate, they just give the x coordinate, so we're going to need to find the y at some point as well. So here we do that there, no problem. U is equal to the function inside, so that's 5 minus 2x here. And du is equal to uh, minus 2. And then y is going to be equal to that to the power 3, yeah? So we got u to the power 3. So now dy is going to be, bring the 3 down, so that's 3u squared, yeah? Okay, no problem. Now, times them together, so dy over dx is going to be equal to minus 6u squared, which is just going to be minus 6. And then u is obviously this, so 5 minus 2x squared, yeah? Okay, cool. And then x is equal to 1, yeah? Because it tells us that, yeah. So I want to find y when x is equal to 1, yeah. So y when x is equal to 1, I want to substitute y into that top equation, yeah. So 5 minus 2 times 1, yeah. So 5 minus 2 times 1. We're doing that because we need to write y equals mx plus c, yeah. And for that, we need the x and the y, yeah. So we don't have the y. We need to do that now. So put that into there and then cube that. Yeah, cube that, and we're gonna get 27, yeah. So that's the y coordinate. We've got the x coordinate. We just need the gradient. So we know the gradient equation is that. So we need to find the gradient at the point x is equal to 1. So at the tangent here. So minus 6 open bracket 5 minus 2 1 shit squared Okay, that's gonna get you minus 54 apparently. So no problem. Minus 54, yeah. This seems like a very easy one. I can't lie. We've got 27, which is double 54. So, you know what I'm saying? It seems pretty basic. I can already tell how this is going to play out. So, obviously, we need y is equal to mx plus c. M is minus 54. It's the same gradient as the thing we found because it's tangent. And then y is 27. So, 27 is y minus 54. X was 1 plus c. So, obviously, yeah, I mean, what are we really doing here? It's just 27 equals minus 54 plus c. Bring 54 to the other side, you get 81. Or 81, like the bus is equal to c. And now, obviously, we got y is equal to minus 54x plus 81, yeah? But question 5, yeah? No problem. Question 5, we're gonna do, okay, so this is y is equal to 1 plus ln 4x, yeah? It's power of 3 over 2. Alright, cool. So you need to differentiate that, yeah? So use the chain rule again. So u is equal to the inside of the function, which is 1 plus ln 4x here. And then we need to do du over dx here. So du over dx is going to be 1 is going to differentiate into nothing, yeah? ln 4x is going to differentiate into 1 over x, yeah? So remember that. I explained this in the previous video. If you don't know about that, go see and get to know. Obviously, we differentiate ln 4x or anything with that x next to it. If it's ln, it's just 1 over x, yeah? Not 1 over 4x, yeah? Alright, safe. And that means that y is going to be u to the power of 3 over 2 since we called this whole thing u. So therefore, it's that now. So dy over du is going to be 3 over 2 u and then take away 1 from the power, yeah? So 3 over 2 minus 1, that's going to be half, yeah? Save. So now you need to times them together, yeah? So 1 over x times that, yeah? Listen, I'm going to convert this straight away. U to the power of a half here is the same as square root u, yeah? So if that's square root u, and I've got 3 over 2, so that's 3 over 2 square root u, yeah? You get, and I'm gonna convert it straight away into just in terms of x here as well. That's obviously going to be 3 over 2, and then the square root u was 1 plus ln 4x here, so it's just 2, 1 plus ln 4x here. Alright, safe. And now we're going to times that by 1 over x here, so dy over dx is going to be them two times together, yeah? So 1, so 1 times 3 is going to be 3, and then the 2 times x is going to be 2x. So 3 over 2x square root 1 plus 4x here. Alright. And now what you want to do, yeah, is put x into that, yeah? So x is equal to 1 over 4 e to the power of 3, it says, yeah? Need to double check that. Yeah, calm. So that's x here. So I need to put x into here to find out what it's going to be, what the gradient is going to be, yeah? So we can do tangent or whatever it wants us to do, yeah? So does it want us to do tangent or no? No, just find dy over dx. Alright, safe. So this is easy now. Just put that into here. So 3 over 2 open bracket 1 over 4 e to the power of 3. Yeah, and then square root 1 plus ln 4 times 1 over 4 e to the power of 3, yeah. And obviously, yeah, you can clock straight away that that's going to be 3 over 2. Um, yeah. And obviously, this is going to be ln and e are going to cancel, yeah. So therefore, it's just going to be, and 4 times 1 over 4 is just 1, yeah. So it's just ln of e3. So ln of e3 is just 3. So 3 plus 1 is 4. Square root of 4 is 2. So you've got 2 times this whole thing. So that's 2 times 3, yeah. And we obviously got 2 open bracket here. So that's 2 times 3 is 6, and then 6 divided by 2 times 1 over 4. 2 times 1 over 4 is going to become, let me just write this out actually, yeah? So this is just square root of 4. And this thing here is just going to be 3 over 2 into there. 2 times that is going to be 1 over 2, e3, yeah? And now you see square root of 4 is just 2, yeah? So it's going to be 3 over 1 over 2, e3 times 2. And obviously, you can tell straight away if I times 2 up here, that's going to be 6 over 1 over 2 e3, which is all calm. But if I want to write this in terms of like actual power, not fraction thing, 6 divided by half is going to be 12. And then 1 over e to the power of 3 is going to be e to the power of minus 3, yeah? Because it's like 1 over, so you get, so that's the final answer there, yeah? Question 6a. Find dy over dx here. So y is equal to, so x is equal to y squared plus y. And so therefore dx over dy, because remember we're differentiating x here in respect to y, is going to be 2y plus 1. And now to find dy over dx, we just do 1 over dx over dy, yeah? So dy over dx is going to be 1 over 2y plus 1, yeah? Let's say b. So x is equal to e to the power of y, yeah, plus 4y. So again here, dx over dy is going to be e to the power of y, because that's going to stay the same, and then plus 4, yeah? And now again, so if you want to do dy over dx, that's going to be 1 over that. So 1 over dx over dy, that's going to flip dx over dy to make it dy over dx. And that's going to be 1 over e to the power of y plus 4, yeah? C, C, yeah, we've got x equal to sine 2y, yeah? And so differentiate that, we've got dx over dy is equal to 2 cos 2y. And then obviously dy over dx, I'm not going to write again, dy over dx is 1 over that, yeah? So 1 over 2 cos 2y, which is obviously equal to 1 over 2, which is 1 over 2. And 1 over cos 2y is sec 2y, yeah? So I can write like that. Uh, question D, yeah? Question D says 4x is equal to ln y plus y cubed, yeah? So divide by 4 on both sides, so x is equal to 1 over 4 ln y. Whenever you've got like sine or what, ln or something like that, like some kind of function, yeah? Write 1 over, like when you divide by the thing, write 1 over 4. Don't just write ln y over 4, yeah? It's just easier to deal with. And then here we got, you can even write it here if you want, 1 over 4 y cubed instead of y cubed over 4, yeah? Alright, and then do dx over dy, yeah? Dx over dy is just going to be, so differentiate that. Ln y differentiated is 1 over y, times that by 1 over 4 is 1 over 4y, plus, and then bring the 3 down, that's 3 over 4y, and then take away 1 from the power, that's squared here. Alright, come. So obviously now, you want to simplify this here, I think, so what does it say? Yeah. Alright, so just simplify this here so that we can actually do 1 over that to find dy over dx here. So simplify this, so times the left hand side by y, because it's missing y, you get, actually no, write 4y here, plus bring the y there, so times the y in, that's y squared over 4 here. And now, times the right hand side by y, yeah, to make the denominator equal to each other, yeah. So 4y plus 3y cubed, because it comes in by y, and then 4y on the bottom, yeah. So now we can add that easily. That's just 1 plus 3y cubed over 4y, yeah. Alright, save. Now you want to do 1 over that, yeah, to find dy over dx, yeah. So dy over dx is going to be 1 over that. So you do 1 over a fraction, just flip the fraction, yeah. So it'll be 4y over 1 plus 3y cubed, yeah. Question 7. Okay, question 7 says find dy over dx at that point on the curve of equation, whatever, yeah, I say. So we've got x is equal to 3y squared minus 2y, yeah. So we want to find dx over dy. So dx over dy is going to be, bring the 2 down, that's 6y to the power of 1, nothing, so just minus 2. Alright, and then obviously dy over dx here is going to be 1 over that, so 1 over 6y minus 2, yeah. Okay, so if now, it says find it at that point, so remember we're using y here. The thing is in terms of y, not x. We're going to need to use the y coordinate. Yeah. So the y coordinate is 2. So y equals 2. So therefore it's going to be 1 over 6 open bracket 2 minus 2. That's obviously 1 over 10. Yeah. So that's the gradient right there, and that's the answer. Alright, question 8. Question 8. Find the value of dy over dx at the point 5, 4 in the equation. We covered that. Okay. So same shit again. So x is equal to y to the power of a half here plus y to the power of minus a half here. And now I'm going to do dx over dy here. So dx over dy, that's going to be bring the half down. So that's half y. Take away 1 from the power, that's minus a half. And then obviously bring the minus half down. So that's minus half y. Take away 1 from the power, that's minus 3 over 2 here. So there you go. And now We're just gonna do 1 over all of that. So to find dy over dx here, that's gonna be 1 over all of this here. So 1 over half y, half minus half y to the power minus 3 over 2, yeah? And now again, so look at the y coordinate that they want because it's in terms of y here, so we need to use the y coordinate to find the gradient. So y is 4, yeah? So since y is equal to 4, just substitute that in, yeah, I'm gonna write it on down here, yeah? So dy over dx here is equal to 1 over half 4 minus half 4 minus 3 over 2. And that's equal to 16 over 3, yeah, if you put in your calculator. So that's the final answer. Question 9. Question 9a says differentiate that with respect to that. So y is equal to x here. So therefore, I can write that as x equal to ey. So just swap them, yeah. So if I swap them there, I can do dx over dy is just equal to ey stays the same when it's differentiated. So just ey, yeah. Alright. B says hence prove that if y is equal to ln x, then dy over that is whatever, yeah. So B is so it's saying y is equal to ln x here. Okay, so we need to prove that differentiation of this is equal to 1 over x or whatever, yeah? So what I can do here is I can write this in terms of I can do e on both sides, yeah? So e to the power of y, and you get that kind of hint from part A, yeah? Where it asks you to differentiate it and you get so why would it ask you to differentiate something in part A if you're not going to use it in part B, yeah? So do e to the power of both sides here. E to the power of y is going to be ey. E of ln x here is going to be e ln x, but e and ln cancel. So it's just going to be x on the right hand side, yeah? So you just get x. And now because of that, we can then differentiate this. So that's going to be dx over dy is equal to ey. So therefore, dy over dx, that's what we used in part 1. It's going to be 1 over that. So 1 over ey, yeah? Okay, calm. So 1 over ey, and we said that x was equal to ey earlier. So that's just 1 over x, yeah? So that's why the differentiation of ln x is 1 over x, yeah? Alright, question 10. And so we got some curve here. And we got to do some situations. So show that the point 2 pi over 6 lies on that. So that's easy, bro. We got x is equal to 4 cos 2y. So obviously you just put x inside of there. What's x? X is 2. So just put 2 here. So 2 is equal to 4 cos 2y. Then we want to find y. So obviously you just divide by 2, but divide by 2 on both sides, isn't it? So yeah, half is equal to cos y, cos 2y. And then obviously just cos inverse half here. That's going to give you pi over 3. So obviously it's bait. So therefore 2y is equal to pi over 3. And to find the second solution, yeah, you just do 2 pi minus, yeah. So it costs us 2 pi minus the first solution, yeah. So 2 pi minus theta. So 2 pi minus that's 5 pi over 3. And then to find y, you just divide by 2. So you get pi over 6, which was the y coordinate, yes. Therefore it's verified. And this one you didn't really need it. 5 pi over 6 doesn't matter, yeah. Alright, come on. And the reason you don't have a range here is because there's no point, yeah. If you keep adding 2 pi, it will give you the same thing anyway, yeah. Alright, question B. Dy, show that dy over dx equal to that, yeah? So obviously we got x equal to 4 cos 2y. So dx over dy is going to be, bring the 8 outside. So 2 times 4 is 8. Cos differentiate is minus sine, so minus 8 sine, and then inside stays the same, yeah? So 2y. Alright, calm. And do dy over dx here. Dy over dx is going to be 1 over minus 1 over 8 sine 2y. Okay, calm, so just 1 over that, yeah? Alright, no problem. Okay, cool. And now it's asking you to do so. It's asking you to do show that dy is that at q, yes. At q, y is equal to pi over 6, so you need to just put pi over 6 into here, yeah. So right, minus 1 over 8 sine 2 times pi over 6, yeah. Alright, calm. Alright, safe. So minus that times that, yeah. So therefore what we got now? We got minus 1 over, if you just put down your calculator, yeah, it will give you minus 1 over 4 root 3, which is the answer that you're trying to get. Calm. Question part C, yeah. Right, an equation for the normal at C, yeah? So we got the gradient at C, we want to find the normal, yeah? Okay. So the gradient of the normal is going to be negative reciprocal, yeah? And since the gradient at C was minus 1 over root 4 root 3, yeah? The gradient at the normal is going to be negative reciprocal of that, so you get rid of the 1 over and you get rid of the negative, it's going to be just 4 root 3, yeah? So, right, y is equal to 4 root 3x, that's mx plus c. And now obviously y we knew from earlier at q is pi over 6 and 4 root 3 and x is equal to 2, yeah, so plus c. And now you just want to do a situation here, so pi over 6 is equal to 8 root 3 plus c, so therefore c is equal to pi over 6 minus 8 root 3. And now obviously just put that into y equals mx plus c, yeah, so y is equal to 4 root 3 x plus c, yeah, c is obviously pi over 6 minus 8 root 3. Alright, save. And yeah, and what does it want you to do now? Wants you to put it in like some form in it. Yeah, so we want to just make it all equal to 0. Yes, that's easy. Just make it equal to 0. Just bring y onto that side, and now you got equal to 0. So 0 is equal to 4 root 3x plus pi over 6 minus 8 root 3 minus y. Yeah? Question 11. Question 11a, yeah. Question 11a states, oh, this is long, you know. There's like 10 parts to this. Alright, so let's cut through this quickly, man. Y is equal to sine squared 3x. Sine squared 3x, if you man don't know, you can write that as sine 3x squared. So that's where the chain rule comes into play. You know what, yeah, for these ones, nah, fuck it, man. I'll just do it normally. Alright, so what you want to do here is u is equal to the inside here. So sine 3x, u over dx is equal to 3 cos 3x. And then therefore y is equal to u squared. So therefore dy over du is equal to 2u, yeah. But in future videos, I'm not gonna do chain rule like this here. I'm gonna do chain rule like you get me, like normally in it. So bring the 2 down there. That's 2 open bracket sine 3x, and then take away 1 from the power, so just that, and then differentiate sine 3x. That's minus 3 cos x. I mean cos 3x, and then times the outside. You get so 6 cos x plus 3x times that. You get me? Yeah, that's how we're gonna do it in the future. But for this exercise, I'll do it like this. Alright, come on. So now you just want to times them together, yeah? So dy over dx is going to be equal to 3 times 2 is 6 cos 3x u, yeah? And u is obviously sine, so that's just going to be 6 cos 3x. And we said u is equal to sine 3x, so it's just sine 3x after that. Alright, save part G. Part B says y is equal to e to the power of x plus 2, yeah, plus 1 squared. Calm, so u therefore is equal to the whole thing that's in the function, so that's x plus 1 squared. And now here they want you to use chain rule again, but you know what, man? Can't be asked. So for du over dx here, listen. For chain rule, simpler way, yeah, just differentiate the outside first. So differentiate the outside, so bring the 2 down and keep this bracket as it is, so x plus 1. And then take away 1 from the powers 1, so it's just that. And then you differentiate the inside. The inside is just 1, and you times the outside. So 1 times this is nothing anyway. Calm. Then differentiate this here, so dy over du is going to be, it's du by the way. It's going to be e to the power of u, yeah? Alright, calm. So obviously dy over dx here now, yeah, is going to be them 2 times together, yeah? So 2 x plus 1 times EU. And EU, I'm just going to swap that for what EU is equal to x plus 1 squared, yeah? So there you go. You can do it from the start, by the way. Look, differentiate the outside. The outside function is the e. Differentiate that, you're just going to get e to the power of x plus 1 squared, yeah? And then differentiate the inside. The inside is this thing. Differentiate that, you get 2x plus 1. So then just times the outside. And that's it. You get the same answer. You get it. Alright, well, c, yeah, is equal to y is equal to ln cos x squared, yeah? Alright, cool. So u is therefore cos x, yeah? And so du over dx here is going to be minus sine x here, because differentiate that. And so therefore y is going to be equal to ln u squared here. So u is equal to that shit there. And now you're going to do dy over dx here. So therefore it's going to be, bro, I think we know this by now, yeah? I don't think I need to show this. It's obviously 2 ln u, yeah? So then ln u differentiated is 1 over x times that by 2 is 2, yeah? But just memorize it in it. If there's a power on the u like that, or power on the x and the ln, and you want to differentiate, it just goes in front. So it just times this. So 2 over x here. Alright, cool. Dy over dx here is going to be them two times together, yeah? So minus 2 sine x over x. And now, what am I saying x, bro? Should be a fucking u there, bro. Alright, cool. And then the u is obviously what, fam? U is obviously cos x, as we established earlier. So that's over cos x. And as you see, sine over cos is tan, so it's just minus 2 tan x here. Alright, d. So d is y is equal to 1 over 3 plus cos 2x, which is the same as obviously 3 plus cos 2x power of minus 1 here, because 1 over something is the same as doing it to the power of minus 1. And now obviously so obviously u is equal to the thing inside, so 3 plus 2x, and therefore du over dx here is going to be 2. And then here y is going to be equal to u to the power minus 1, and so therefore dy over du is going to be minus u to the power minus 2 here. Alright. Now dy over dx here is going to be these two times together, yeah? So effectively, I'm gonna write this as the original form, yes? This is just minus 1 over u squared, yeah? Because u to the power minus 2 is 1 over u squared, yeah? And then negative, yeah? Calm. So times them together, that's going to be minus 2 over u squared, yeah? Bro, I was waffling the whole time. This is fucking cos x, cos 2x. Yeah? Listen, again, because it's unedited, yeah? If it's out, it means it's completely patterned, yeah? So it means that there's no corrections, you get me? Yeah, it's done as it is. So trust me, that's cos there, yeah? Alright, calm. So I was trying to shit the whole time. Cos 2x differentiated is minus 2 sine 2x, yeah? So that's there. And now times them together, yeah? So times them up there, that's going to be minus 2 sine 2x over u squared. And obviously u squared is equal to what? U squared is equal to just u squared, yeah? It's equal to 3 plus whatever the fuck. So that's minus 2 sine x sine 2x over 3 plus cos 2x squared, yeah? Alright, calm. Alright, question E, yeah? Y is equal to sine half, sine 1 over x, yeah? And so therefore u is going to be 1 over x, which is just equal to x to the power minus 1. And so differentiate that, you get du over dx is going to equal minus x minus 2, which is just equal to minus 1 over x squared. And then obviously here y is equal to sine u, yeah? And obviously sine u differentiated is going to become cos u, yeah? So dy over du is going to be cos u. Alright, now you want to times them together, yeah? So dy over dx is going to be cos u times by minus, I'm going to put times of this dot, yeah? Minus 1 over x squared. And obviously I don't even need to do that. That's just going to be minus 1 over x squared cos u. And u is obviously 1 over x, so that's minus 1 over x squared cos of 1 over x here. Question 12. Question 12, I'm going new whiteboards. Okay, final question here. The curve has that equation. Now there's 30 and 2. I better take my patience. 12 looks bare long as well. What's going on with 12, man? So, alright, cool. Question 12, yeah? In that case, I'm gonna go back here, man. Alright, cool. So question 12, yeah? Got y is equal to 4 over 2 minus 4x squared, yeah? And so u is obviously the inside the function. So this function is like 4 over x squared, yeah? So if it's 4 over x squared is the function, the inside is 2 minus 4x, yeah? So 2 minus 4x, and then du over dx is going to be minus 4. And now y is going to be 4 over u squared, yeah? Which is the same as 4 times u minus 2. And now obviously I want to do dy over dx here. So dy over du, sorry, here is minus 8 u to the power minus 3 here. Alright, which is equal to minus 8 over u to the power 3. Cool. Now, times them together to get dy over dx. So dy over dx equals to 32, because minus 4 times minus 8 is going to cancel the negative. It's going to just be 32 over u cubed. Yes. So, and obviously u is equal to, that's 32 on the top, and then u is obviously 2 minus 4x here. So 2 minus 4x cubed here. Save. What are we doing now? The point A has coordinate 3, find the gradient of the normal, yeah? So obviously we need to put in the x coordinate, which is 3, so x is equal to 3, so find the gradient at that point. So that's 32 over 2 minus 4 times 3 cubed, which is going to be fucking 0.04 apparently. Alright, so we got that. Nah, sorry. That's y. Yo, I'm tweaking differently. That's y, okay? That's y. dy over dx is not that. dy over dx is minus 0.032. And now we want to find y because it didn't give us the y coordinate. So y is up here. So put 4 over open bracket 2 minus 4 open bracket 3 squared this time. That's going to give you y, which is 0.04. Alright, save. So now we can form the equation here. Oh yeah, by the way, it's a normal, yes? The gradient is going to be, the actual gradient m is going to be 1 over negative of this, yeah? So 1 over 0.032, yeah? Because negative reciprocal, yeah? Alright, calm, and it was negative originally, yes? Going to make it positive. So now, right, y is equal to 1 over 0.032x plus c, yeah? And the y coordinate is 0.04. So we got 1 over 0.032, and then x with 3 plus c. So therefore c, apparently they want you to just write it like this. Times 3 onto here, and then just bring it onto the left hand side. So 0.04 minus 3 over 0.032 is equal to c here. So now write the whole equation again. So we got y is equal to 1 over 0.032x plus c, which is 0.04 minus 3 over 0.032, yeah. And now, obviously, times everything by times everything by 100, actually, yeah. If you times everything by 100, it will cancel out nicely, yeah. So times everything by 100, so that's going to be 100y. Times this by 100, you get 3125x apparently. Times this by 100, you get 4. Times that by 100, you get minus 9375. And obviously 4 minus 9375 is going to be minus 9371. So you get 100y is equal to 3125x minus 9371. And then take away 100y to make it equal to 0. So that's going to be 0 is equal to 3125x minus 9371 minus 100y, yeah? And you can double check that, yeah? Alright, come on. Save. Alright, let's use this for this now, yeah? So question 13, yeah? So question 13 there. Alright. Safe. So we got y is equal to 3 to the power of x cubed, yeah? And we need to find the exact value of the gradient of the curve at the point with coordinates that, yeah? So you differentiate and put the point, yeah? So u is equal to x cubed, yeah, because that's what's inside the function. The function here is f 3 to the power of x, and so the thing inside is x to the power 3. Alright, calm. So du over dx here is going to be 3x squared, and then y is going to be 3 to the power of u. So therefore dy over dx du, sorry, is going to be 3u. Remember, when you differentiate something like this, you keep the thing the same, then you do ln of the base, so ln 3. Alright, and now times them together, yeah? So dy over dx here is going to be 3x squared, yeah? 3 to the power of u. I'm just going to write u as it is here. Nah, actually, ln 3. Alright, and then here that's 3x squared. 3, you write u as x to the power 3. ln 3. Alright, save. Then obviously x equals 1, yeah, you need to make x equal to 1 to find the gradient at that point. So that's going to be 3 open bracket 1 squared 3 to 1 cubed ln 3, yeah. And that's if you basically manipulate that in a way. That's going to tidy up the outside, and then it's just going to be 9. So that's 9 ln 3. That's it.
You say you're my brother, then don't change on me. For you, I risk it all like I got nothing to lose. I just hope that you will do the same for me.